Chapter 6, Goal 2. Classify polygons as concave or convex. This goal is all about classifying polygons again. The first goal, we were talking about naming that polygon based on the number of sides. Now we're going to actually classify it as convex, concave, regular, and irregular. A polygon is regular if it is both equilateral and equiangular. If you recall from last chapter, equilateral means all the sides are the same. So in this case, the polygon is a regular polygon if all sides are the same length. But not only that, it also has to be true that it is equiangular, or all angles are the same measure. If it is not regular, we would call it irregular. The other classification of a polygon is concave and convex. We call that polygon concave if any part of one or more diagonal contains points in the exterior of the polygon. In layman's terms, or in real talk, not math talk, that means if you draw a diagonal and it goes outside of the polygon, it's concave. In this case, I can draw this diagonal here. That goes through the polygon, so that doesn't make this concave. But this diagonal does. This diagonal is outside or in the exterior of the polygon. It makes this concave. The opposite of that would be convex. No diagonals are in the exterior. Here, it doesn't matter what diagonal I draw. This diagonal, and those are the only two diagonals in this case. None of those points on the diagonal are outside of the polygon. It's convex. It only takes one diagonal that goes outside to make it a convex, or to make it a concave polygon. For each of the following, we're going to classify these as regular or irregular first, convex or concave second. Here, these two angles are congruent. We'll call them angles 1 and angle 2. Angle 3 is congruent to angle 4, but angle 1 is not congruent to angle 3. If it's going to be regular, all angles need to be congruent to each other. This is not the case here, so we would say this was irregular. Number 5, I have 1, 2, 3, 4, 5 angles in the interior. This is technically a sixth angle. It's not 90 degrees. So this would be irregular as well. But you could also tell from the side lengths. As you look at the side lengths here, this has 1 tick mark, this has 3 tick marks. Automatically, your sides are different lengths. That also makes this irregular. When I'm looking to see if it's convex or concave, that's when we're looking at our diagonals. This figure would have 2 diagonals. Those diagonals are always inside my polygon. That makes it convex. In number 5, I have a lot of diagonals here. Some of them, like this one, stay inside. But this is another diagonal. It connects two non-consecutive vertices. That's outside of your polygon. You only need one example or counterexample to make this concave. In this case, I have that one example, it would be concave. Go ahead and try to fill in regular or irregular for number 6, convex or concave for number 6. Press pause while you finish that and come back to check your answer. Okay, how did you do? Hopefully you got that right. All 4 sides are marked with the same tick mark. All 4 angles are 90 degrees. Since all angles are the same and all sides are the same, it's regular. Every diagonal that you could draw here would stay inside the figure, so it is convex.